We're given the differential equation governing a circuit. That circuit is subjected to a step input. I of t, the input, is 0 for t less than 0 and 2 amps for t greater than 0. What we want to find is the maximum value of v of t, so the peak value of v of t. Now, rather than explicitly solving this differential equation, what I'm going to do is use the coefficients of the differential equation to infer what the peak value of v of t is. So I'm going to want to convert this guy to standard form. So I divide out the leading term in front of the highest order derivative, so d squared v by dt squared plus 12 over 4 is 3, dv by dt, plus 400 over 4 is 100, v is equal to 10 over 4, which is 2.5 I of t. So this looks like a differential equation where this is the square of the natural frequency, and this is 2 times the damping ratio times omega sub n. So the peak value, by definition, y sub p, is the steady state value, so yss is equal to y as t goes to infinity, times 1 plus m sub p, which is the percent overshoot. Also, mp for underdamped systems is approximately 1 minus squiggle over 0.6 for squiggle less than 0.6. There's an exact version of this if I don't want to use that approximation, but this will probably be close enough for me, depending on what squiggle turns out to be. So first we need to find the damping ratio squiggle, calculate an m sub p, calculate the steady state response, and then plug everything into this equation. 2 times squiggle times omega sub n is 3, and a second equation, omega sub n squared, is equal to 100, so omega sub n is equal to 10 radians per second. 2 times the damping ratio times 10 is equal to 3, so the damping ratio is 3 over 2 times 10, or 0.15. So m sub p is 1 minus 0.15 over 0.6. 0.15 is 1/4 of 6, so that's 0.25, or we have mp equals 0.75, or 75% overshoot. Now we need to find the steady state response. Since the input's constant, it's just 2 amps. As t goes to infinity, all the voltages and currents will become constants and the derivatives go away. So d squared vt dt squared goes to 0, dv dt goes to 0, and the original equation becomes 400 times v of infinity is equal to 10 times I of infinity, which is just 10 times 2 amps, or 20, and v of infinity is equal to 20 over 400, which is 0.05 volts. And we'll get the same result if we let our derivatives go to 0 in this standard form equation, since it's just scaled by a factor of 4 from the first one. So, taking these two pieces of information, the peak value is the steady state response, yss times 1 plus mp, which is 0.05 times 1 plus 0.75. So y sub p is equal to 0.0875 volts. And we're done.